Section 4-4, Multiplication Rule, Part 1. The main idea in this section is to find the probability of another compound statement. This time, we'll be looking at two events that we're conducting in sequence, one after the other. We will use multiplication, and the key word is AND. The notation we will use is the probability of A and the probability of B. So P of A and B is the probability of A happening in the first trial, then B happening in the second trial. Another important notation is P of B, then a vertical bar, then A. This is the probability of B given that A had already happened. The multiplication rule is as follows. The probability of A and B is equal to the probability of A times the probability of B given that A had occurred. The idea is that each probability will be multiplied, but we need to make sure that any changes in the sample space would be reflected in the second probability. Whether the probability is affected or not depends on whether the events are dependent or independent. We'll define these shortly. We can also generalize the multiplication rule to extend to more than two events. We would simply continue to multiply the probabilities. Now for some definitions. Two events are independent if the occurrence of the first event does not affect the probability of the second event. This can be extended to more than two events as well. If the events are not independent, then they are dependent. Just a little note on dependent events. Just because the events affect the probability, it does not imply causation. There is a time when it might be beneficial to assume that the events are independent. This can happen if we pick a small sample from a large population. This is called the 5% guideline. So, if a sample size is less than 5% of the population, then we can treat the events as independent. Let's take a look at a couple of examples. Here we have 20 people and we'll randomly select 2. The key here is that we'll select the second person with replacement. That is, we select the first person, then put this person's name back, and therefore we won't change the sample space. For the first event, there are 14 out of 20 who tested positive. For the second event, we'll replace the first person, so there will still be 20 people to choose from. So that's 6 out of 20. Therefore, the probability will be given by multiplying the two probabilities. So there is a 21% chance that we will select 2 people at random. The first tested positive and the second person tested negative. Let's take a look at a similar example, but this time take the second person without replacement. In this case, the second event is dependent on the first one, because without replacement, the sample space will change. So here we start off the same way. The probability for selecting someone who tested positive is 14 out of 20. The big difference is that there is no replacement. So the first pick is not replaced. So when we choose a second person, there are only 19 to choose from. There are 6 negative results, so the probability is 6 out of 19. Finally, we multiply the probabilities. So the probability of selecting a positive test result for the first pick and then selecting a negative test result for the second pick is about 22%. Sometimes tree diagrams are helpful to visualize the sample space. We use lines to connect branches from one trial to another. Here's an example. Suppose we take a quiz where the first problem is a true-false question, then the second problem is a multiple choice question with 5 choices. A tree can help create a list of sample space. More importantly, you can count the number of elements in the sample space. 2 possibilities for the first question and 5 for the second. So that makes 10 possibilities for the sample space. Let's summarize the 2 major rules in probability. When you see the word or, think about addition. Be careful to watch out for overlaps, making sure you subtract this out. When you see the word and, think of multiplication. For this, make sure you account for any changes in the sample space after performing the first trial and before doing the second one. Here's a little flowchart for the multiplication rule. Okay, that's the end of section 4-4.